Alright, and so there are four of them. We're gonna focus on the second one here. And so in these formulas, x1, x sub 1 is an angle, x sub 2 is an angle, and then the sum of x1 and x2 is also an angle, right? The sum of two angles is an angle. Okay. And so what the second difference formula tells us, the cosine of the first angle minus the second angle can be computed, right, has the same value as the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. Right? The value of the left-hand side and the value of the right-hand side are equivalent. Okay. So we're going to calculate the cosine of 3 pi over 4 minus 5 pi over 6. Right? So I wrote over here x1 plus x2 is an angle, right? It's also true that x1 minus x2 is an angle. And so 3 pi over 4 is an angle, 5 pi over 6 is an angle, and 3 pi over 4 minus 5 pi over 6 is an angle, right? The common denominator for these two fractions, right, is 12. So 3 pi over 4 can be written as 9 pi over 12. 5 pi over 6 can be written as 10 pi over 12. And 9 pi minus 10 pi is minus 1 pi. So the angle 3 pi over 4 minus the angle 5 pi over 6 equals the angle minus pi over 12. Right? So you can take two angles, subtract one from the other, and get a third angle. So the cosine of 3 pi over 4 minus 5 pi over 6, according to our formula, is equal to the cosine of the first angle times the cosine of the second angle plus the sine of the first angle times the sine of the second angle. Well, in case you don't know what the sine and cosine of those two angles are, at the top of your head, we have our unit circle. And the cosine of 3 pi over 4 is minus the square root of 2 over 2, right? That's its value. The cosine of 5 pi over 6 is equal to minus the square root of 3 over 2. That's its value. Okay? I put it in parentheses, right, because we're multiplying two negative numbers. The sine of 3 pi over 4 is square root of 2 over 2. And the sine of 5 pi over 6 is 1/2. And now you got to do PEMDAS, right? Multiplication before addition. Yes, sir.
Why are we adding the two? Because it has subtraction in the phrase.
Right.
We switched
And
something.
in the textbook actually gives a proof why we're adding. Okay. Yeah, they actually have the proof of it. Okay. All right, and it just turns out that way. And they derive the formula and give the proof. We end up adding the two quantities on the right. It's the opposite of maybe what you would be inclined to think. Okay. All right. So a negative times a negative is positive. And square root of 2 times square root of 3 is square root of 6, right? Square root of 2 times 3. 2 times 2 is 4. And then when we multiply these two fractions, square root of 2 times 1, square root of 2, and 2 times 2 is 4. Common denominator, now we combine the numerators. Now you cannot do anything with square root of 6 and square root of 2 except add them together over the common denominator of 4. Any questions on that, ladies and gentlemen? So that's the example of sum and difference. All right, if you flip over your document, your handout, back in section 4.2, when we were learning about the sine and cosine function, at the bottom of page 5, we solved two equations, right, involving sine and cosine. Right? We found all the values of t on the unit circle, where the sine of t is equal to square root of 2 over 2, and the cosine of t is equal to minus square root of 3 over 2. Okay? And so that was an example of solving an equation, right, for the variable t, the angle t. So now in this section, okay, we're doing the same thing, okay, except we're doing it for a quadratic equation, right? The sine of the angle is a quadratic equation, right? So it's not sine x equal to a number, right? It's an equation where that is quadratic in the sine of x, okay? So we got to find all the angles x in radians that satisfy this equation. And it's going to involve, right, quadratic equations, right, where we're going to factor. So we're going to find all the angles such that the sine of x squared minus 3 times the sine of x plus 1 is equal to 0. Now first, we're going to find all values of x on the unit circle that satisfy this equation. Okay. And then we'll be able to write out all the coterminal angles that satisfy that equation. Okay. Now, you know this is the sine of x squared, right? This is the sine of x. So I'm going to replace the sine of x with just the variable x. If I replace the sine of x with the variable x, I have 2x squared minus 3x plus 1 is equal to 0. Okay. So I replace sine of x here with x, and I replace sine of x squared here with x squared. This is a quadratic equation in a single variable. You know how to solve this, right? Factor the left-hand side if you can. Set the factors equal to 0. Solve for x, right? Or use the quadratic formula. So when you factor the left-hand side, you have 2x minus 1 times x minus 1 is equal to 0, right? And then he set 2x minus 1 equal to 0. And x minus 1 equal to 0. And you get x is equal to 1/2 and x is equal to 1, right? Well, in solving this trigonometric equation, we're going to factor the left-hand side just like we do with x over there, okay? And set each factor equal to 0 and solve for sine x. So when we factor this, instead of 2x minus 1, we have 2 times the sine of x minus 1. Instead of x minus 1, we have the sine of x minus 1. And that product is equal to 0. Now by the zero product property, either this first factor is equal to 0, or the second factor is equal to 0. All right, just like over there with the variable x. Now when we solve for sine x, we have the sine of x is equal to 1/2 here, and the sine of x is equal to 1 here. And now that we got sine x equals 1/2 and sine x equals 1, right, we can solve for x just like we solved for t back in section 4.2. Okay. So where is, for what angles on the unit circle is the sine of x equal to 1/2? Okay. Well, pi over 6, the sine of pi over 6 is equal to 1/2, and the sine of 5 pi over 6 is equal to 1/2. So x equals 5 pi over 6. Excuse me, x equals pi over 6. And x equals 5 pi over 6 are two angles that satisfy our quadratic equation. Where is the sine function equal to 1? We have pi over 2 radians, right? So we have sine of pi over 2 radians is equal to 1. So those are the three angles on the unit circle that satisfy our quadratic equation. Okay. That when you put any of those three angles in for x, the left-hand side will equal 0. But you know, any angles that are quadrantal, or not quadrantal, that are coterminal with pi over 6 or 5 pi over 6 or pi over 2, they have the same value for the sine function. Okay? And they also will make the left-hand side equal to 0. Well, coterminal angles only differ by an integer multiple of 2 pi radians, right? In the last exam, right, you were given an angle in radians and you had to find a coterminal angle. So all the coterminal angles with pi over 6 differ with pi over 6 by an integer multiple of 2 pi. So we can write out all the angles that are coterminal with pi over 6 with 2 pi over n, where n is an integer. And the same is true, all the angles that are coterminal with 5 pi over 6 are an integer multiple of 2 pi over n, right? Differ from pi over 6 by an integer multiple of 2 pi over n. So we just add 2 pi over n to 5 pi over 6 to get all the angles that are coterminal with 5 pi over 6. And we add 2 pi over n to pi over 2 to get all the angles that are coterminal with pi over 2. And so these are all the angles that we can put in for x, our quadratic equation, and the left-hand side will equal 0. Okay. Yes, sir.
It's like the extent of that. Can't you subtract by 2 pi also and find a coterminal angle?
You could, but n is an integer, so integers are also negative, right? I mean, it includes negative 10, right? You could write it as minus 2 pi over n.
So you do.
Yeah. Any questions on that, ladies and gentlemen? All right, if you flip over, we'll do another. All right, we have 2 cosine x squared is equal to 1 minus the sine of x. Now, step number 1 is to get 0 on one side, right? Solving a quadratic equation. So we're going to move the 1 over to the left side and the minus sine x to the left side. Move the 1 over to the left side by subtraction. Move the minus sine x to the left side by addition. And we have 2 times cosine x squared plus the sine of x minus 1 is equal to 0. Now you notice there's a small problem here. We got cosine and sine mixed together. It has to be all cosine or all sine. So we got to make a substitution in order to get the left-hand side all sine or all cosine. Well, remember the Pythagorean identity? Cosine x squared plus the sine of x squared is equal to 1. If we replace cosine x squared, we can have the entire left-hand side in terms of sine x. So, if I subtract the sine of x squared from both sides, I have the cosine of x squared is equal to 1 minus the sine of x squared. Okay? I'm subtracting sine of x squared from both sides. And now I can replace cosine of x squared here with 1 minus the sine of x squared. And then the entire left-hand side of the equation is in terms of sine of x. And I can solve that quadratic equation. So I have 2 times 1 minus the sine of x squared and now I got to simplify, right? I got to distribute the 2 inside the parentheses. And I have 2 minus 2 times the sine of x squared plus the sine of x minus 1 is equal to 0. So writing this in descending powers as sine x, I have minus 2 times the sine of x squared plus the sine of x, and then 2 minus 1 is plus 1. Now, if I replace sine of x with x and sine of x squared with x squared, I have minus 2x squared plus x plus 1 is equal to 0. And so factoring this is like factoring this. But I have one problem. I don't like it when the number in front of the x squared is negative, right? But Robert likes to have that number positive, so he divides both sides by negative 1 to get 2x squared minus x minus 1 is equal to 0. Then he factors. So I'm going to do the same thing over here. Divide both sides by negative 1. So I have 2 times the sine of x squared minus the sine of x minus 1 is equal to 0. Now this quadratic equation in sine of x looks just like this one in the variable x. I know how to factor this. Factoring that is like factoring this. So I think this factors into is it 2x plus 1 times x minus 1? 2x squared, 1x minus 2x negative 1. Yeah. Okay. So this factors into 2 times the sine of x plus 1 times x minus 1. So now you set the first factor equal to 0. Oh, done. I wrote x minus 1. I meant sine x minus 1. So I had 2 sine x plus 1 is equal to 0. And sine x minus 1 is equal to 0. So now when I solve this first equation, I get sine x is equal to minus 1/2. When I solve the second one, I get sine x is equal to 1. And so where on the unit circle is sine x equal to minus 1/2? Well, 7 pi over 6 and 11 pi over 6. And we know that sine pi over 2 is equal to 1. So on a unit circle, the 3 angles that satisfy our equation are 7 pi over 6, 11 pi over 6, and pi over 2. And then to get all solutions, all coterminal angles, we add 2 pi over n. Any questions on that? All right, we got one last little blurb. Okay. Again, you want to study these notes, okay? The final exam. Pearson, I don't think I had a chance to upload this.
Mr. Bill,
Yes.
can I have one?
Oh, you know, if she needs one, you're gonna need one, right? Yeah. All right. So let's look at 4.12, the law of signs first. Okay. So you're all familiar with right triangle trigonometry. SOHCAHTOA. Okay. Well, the law of sines relates the three angles and the three sides of a triangle that is not a right triangle. Right? This is called an oblique triangle. It doesn't have a right angle. And so this right triangle has angles big A, big B, and big C, little a, little b, and little c. And so the law of sine says the sine of angle A over little a is equal to sine of angle B over little b. Same for angles A and C, right? The sine of angle A over little a is equal to sine of angle C over little c. Sine of angle B over little b is equal to sine of the angle C over little c. Okay, so you notice side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. And then you also have the constraint that the sum of the three angles has to equal 180 degrees. So in the exercise down below, we're going to find the length of side B if angle A is 82 degrees, angle B is 76 degrees, and side C is 3.5 meters. When working with law of sines, we tend to work in degrees instead of radians. Okay. So let me draw a picture. Here's angle A, angle B, angle C. Here's side C, side A, side B. And we know that angle A is 82 degrees and angle B is 76 degrees. And the side of the length of side C is 3.5 meters. With this information, we can calculate the length of side B. By the law of cosines, the sine of angle C divided by the length of little c, right, is equal to the sine of angle B divided by side B. Now we know little c, we're solving for little b. We know angle B, we don't know angle C. But we know that the sum of the three angles is equal to 180 degrees. Side A is 82, angle A is 82 degrees, angle B is 76, angle C is the unknown. So 82 plus 78 is 158 degrees. So angle C is equal to 22 degrees. So now when we substitute in, we have the sine of 22 degrees over side C, which is 3.5 meters, is equal to the sine of angle B, which is 76 degrees, divided by the unknown length B. Well, we have a fraction on the left, fraction on the right. Solving for B, we can cross multiply, can't we? And we have little b times the sine of 22 degrees is equal to 3.5 times the sine of 76 degrees. And now when you divide both sides by the sine of 22 degrees, you get side B, right? The length of side B is 3.5 times the sine of 76 degrees over the sine of 22 degrees. And since you don't have a calculator, it's as far as you can go. Any questions on that? So that's the law of sines, right? How you calculate. You need 3 pieces of information before you can do the 4th piece. All right, one last blurb. Tangent function. For those of you who know SOHCAHTOA, right, you know the tangent function. And the tangent of the angle x is equal to sine x divided by cosine of x, as long as cosine of x doesn't equal 0. So the tangent of pi over 3 radians is equal to the sine of pi over 3 radians over the cosine of pi over 3 radians. And the sine of pi over 3 radians, you know, is square root of 3 over 2. And the cosine of pi over 3 radians is 1/2. Square root of 3 over 2 divided by 1/2 is square root of 3. Jump down to the 4th one, the tangent of 4 pi over 3 is equal to the sine of 4 pi over 3 over the cosine of 4 pi over 3. And the sine of 4 pi over 3 is minus square root of 3 over 2. And the cosine of 4 pi over 3 is minus 1/2. Negative divided by negative is positive. And square root of 3 over 2 divided by 1/2 is equal to square root of 3 again. The reason why I singled those 2 out, okay, because we're a little pinched on time. So in the exercise at the bottom, it says find all values of t that satisfy the given equation. So we have the tangent of t minus the square root of 3 is equal to 0. So if I add square root of 3 to both sides, I have tangent of the angle t is equal to square root of 3. What 2 angles on a unit circle is the tangent function equal to square root of 3? Pi over 3 and 4 pi over 3, right? So t can equal pi over 3, and it can equal 4 pi over 3. two angles on the unit circle, where the tangent function is equal to root 3. And now you add 2 pi n. You get all the coterminal angles. And we're done. So, 4.2 after 4.1, study your notes, okay? That'll prepare you for the final, okay? Everything else, study your in-class exams and 15 quizzes. So it's been a good semester. Hope everything works out for everybody. And have a good summer.